Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Fortune's algorithm for generating Voronoi diagrams. It's a fascinating, albeit challenging, algorithm.
I've heard whispers of its complexity. What exactly is a Voronoi diagram, and why would anyone want to generate one?
Great question. A Voronoi diagram partitions a plane into regions based on proximity to a set of points, called sites. Imagine drawing circles around each point. The boundaries where those circles meet define the regions. It's incredibly useful in procedural map generation. For example, creating realistic-looking terrain or city layouts.
So it's all about proximity. Makes sense. But Fortune's algorithm, that sounds intense. What makes it so difficult?
The difficulty lies in its efficiency. It's an O(n) log n algorithm, which is pretty good for computational geometry, but the implementation is notoriously tricky. The author even admits it's a beast to tackle. It involves a sweep line that moves across the plane, creating and managing parabolic arcs, which represent the boundaries of the Voronoi cells.
Parabolic arcs? That sounds advanced. What's the role of these arcs?
Exactly. The arcs are defined by the sites and the sweep line. The intersection of two arcs represents a point equidistant from the two corresponding sites, a point on the Voronoi edge. The algorithm cleverly tracks these intersections and manages the beach line, which is the frontier of all active arcs.
A beach line? This is getting more colorful. So the beach line is like a dynamic boundary?
Precisely. It's constantly changing as the sweep line advances. The algorithm handles two types of events: site events, when the sweep line encounters a new site, and circle events, when arcs collide, creating a Voronoi vertex. Managing these events and updating the beach line is where the complexity lies.
So it's not just about finding intersections, but also about managing the dynamic nature of the beach line. That's a lot to keep track of.
Absolutely. The algorithm uses a priority queue to manage events, ensuring that events are processed in the correct order. It's a delicate dance of adding and removing arcs from the beach line, calculating intersections, and generating Voronoi vertices and edges.
And what about the data structure used to store the final Voronoi diagram? I've heard about something called a DCEL.
Yes, the doubly connected edge list, or DCEL, is a common choice. It's a sophisticated structure that efficiently represents the vertices, edges, and faces of the Voronoi diagram. It's designed for easy manipulation and traversal of the diagram's topology.
So it's not just the algorithm itself, but also the data structure that adds to the complexity. I can see why the author recommends using a library for most applications.
Exactly. Unless you're dealing with a very high volume of large Voronoi diagrams, the effort required to implement Fortune's algorithm might outweigh the benefits. Simpler, O(n)² algorithms or readily available libraries are often a more practical choice.
It sounds like a great learning experience, though. Understanding the intricacies of Fortune's algorithm would be a significant accomplishment.
Absolutely. It's a testament to the elegance and power of computational geometry. While challenging, mastering it provides a deep understanding of spatial partitioning and algorithmic design. And don't forget the visual appeal of the resulting Voronoi diagrams. They're truly beautiful.
I agree. Thanks for breaking down this complex topic for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for another deep dive into the fascinating world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating GitHub project, a modern recreation of the classic hotline client for Apple devices. It's a real blast from the past, but with a modern twist.
Oh, I'm excited. Hotline? I remember hearing whispers of it. A pre-internet chat system, right? What's the big deal about this reboot?
Exactly. Hotline, from 1997, was a suite of apps that let you chat, message, and share files directly from your Mac. Think IRC, AM, forums, and FTP all rolled into one, but completely decentralized. No central server to control everything. Revolutionary for its time.
Wow, that sounds amazing. So this new project is essentially bringing that back? What's the tech stack?
Yep. This GitHub project uses Swift and Swift UI, making it compatible with modern macOS, iOS, and even future Vision OS. The goal is to create a fully functional, open-source client. It's not just a port, it's a complete rebuild. And the best part? It's all written in Swift.
That's impressive. But I noticed something. The project doesn't include server software. How does that work?
That's a great point. This project focuses solely on the client side. To actually use it, you need a hotline server. Luckily, the creators point to a project called Mobius, which is a capable server implementation. So you'd need to set up your own server or find an existing one.
Ah, I see. So it's more of a community effort then? What's the current status of the client itself?
Pretty impressive progress, actually. The macOS version is quite feature-rich, with support for trackers, multiple servers, accounts, bookmarks, and even privacy settings. The iOS version is catching up quickly, with many core features already implemented. They're aiming for a unified codebase across all Apple platforms.
That's ambitious. What are some of the key features still under development?
Well, file uploading and downloading on iOS are still works in progress, as is file management in general. Also, features like folder uploads and downloads and custom icon sets are on the roadmap. But the core functionality is already there.
It's amazing to see this classic resurrected. What are the long-term goals of the project?
Beyond just building a functional client, they want to make the underlying Swift code reusable for other projects. They also aim to document the hotline protocol itself, which is a huge contribution to the community. And, they want to bring back the hotline brand.
Haha, I love that ambition. It's a testament to the enduring appeal of Hotline. A truly remarkable project.
Absolutely. It's a great example of how open source projects can breathe new life into classic technologies. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Hotline. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Tapestry, a revolutionary new app that's changing the way we consume online content. It's a game changer, really. Amazing.
I've heard whispers. What makes it so special? Is it just another aggregator? I'm intrigued.
It's more than just an aggregator. It's a chronological timeline weaving together your favorite blogs, social media, podcasts, you name it. Think of it as a personalized, privacy-focused newsfeed, but without the algorithmic manipulation. No more endless scrolling.
So, no algorithm dictating what I see? That's a huge selling point in today's digital world. That's refreshing. But how does it handle different platforms? Does it support, say, Bluesky and Mastodon?
Absolutely. It integrates seamlessly with Blue Sky, Mastodon, Tumblr, RSS feeds, podcasts, even YouTube channels. It's incredibly versatile. All your content, neatly organized in chronological order. You're in control.
That's impressive. But what about privacy? We're all concerned about data these days.
That's where Tapestry truly shines. Privacy is paramount. There's no server tracking your activity, no third-party snooping. Even their ads respect your privacy. It's a breath of fresh air.
Wow. And I see they mention spoiler avoidance. How does that work?
Oh, that's a clever feature. You can create powerful muffle and mute rules to filter out specific keywords or topics across all your feeds. No more accidental spoilers. It's incredibly customizable.
That's brilliant. So it's not just about aggregation, it's about control and customization. What about the app itself? Is it just for iPhones?
No, it's a universal app. Native support for both iOS and iPad OS, with iCloud Sync to keep your reading position consistent across all your devices. Plus, it's fully accessible with voiceover support, dynamic type, and more. It's incredibly thoughtful.
I see. It sounds almost too good to be true. What about the downsides? Anything you'd critique?
Well, being a relatively new app, the connector library might not be as extensive as some established platforms, but they're actively working on expanding it, and the ability to add third-party connectors is a huge plus. It's a work in progress, but a promising one.
That's a fair point. But the privacy features and chronological timeline alone make it worth checking out. It's a free app with premium features, right?
Exactly. A free app with premium features. It's a fantastic option for anyone who values privacy, control, and a clean, chronological view of their online content. Definitely worth a download.
I agree. Thanks for the insightful overview. I'm definitely going to check it out.
You're very welcome. And that's all the time we have for today's Tech Bites and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bites and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating blog post about obscure islands. Get ready for a geographical adventure? Let's explore some truly unique places.
Sounds exciting. I'm particularly interested in the ones with unusual historical significance or geographical quirks.
Absolutely. The post starts with Pheasant Island, a truly bizarre place. It's this tiny island that actually switches countries every 6 months. Can you imagine the Border Patrol headaches?
That's incredible. 6 months under French sovereignty, 6 months under Spanish? What a unique situation. What about Ailsa Craig? The description mentions Olympic curling stones. How's that even connected?
That's a great question. Apparently, the island is a major source of the special granite used to make those curling stones. It's a pretty niche industry, but a significant one for Ailsa Craig.
Wow, I never knew that. So, from international border shifts to curling stones, this is quite a journey. What other unusual islands are highlighted?
Well, there's Tristan da Cunha, the world's most remote inhabited island. Imagine the isolation. Then there's Nikumaro Island, potentially the final resting place of Amelia Earhart. That's a mystery that continues to fascinate.
Oh, that's chilling. And the mystery adds another layer of intrigue. Are there any more islands with equally compelling stories?
Absolutely. There's Hans Island, a tiny rock that almost sparked a war between Denmark and Canada. Talk about a disproportionate response to a territorial dispute. Then there's Just Room Enough Island, the smallest inhabited island in the world. I can barely imagine fitting a house there.
That's hilarious. It sounds like a tiny, exclusive community. What about some of the more unusual ones? The ones that are less real?
Yes. There's Sandy Island, which, get this, was a fake island on Google Maps. It's a testament to how easily maps can be wrong. And then there's Null Island, which doesn't even exist. It's located at 0 degrees north, 0 degrees east, the intersection of the equator and the prime meridian. It's a purely theoretical location.
That's mind-blowing. A fake island and a non-existent one. This blog post is full of surprises. What other geographical oddities are mentioned?
Well, there's Devon Island, the world's largest uninhabited island. Imagine the potential for exploration. And then there's North Sentinel Island, home to one of the last uncontacted tribes. It's a place of mystery and respect for their isolation.
Respect is key there, absolutely. It's fascinating how many different types of islands there are. What about some of the more time-related ones?
Right. We have Kiritimati, the first island to experience New Year's Day. Imagine celebrating the new year first in the world. And finally, the Diomede Islands, split by the international dateline. One island is a day ahead of the other.
That's incredible. A day's difference on islands so close together. This blog post is a fantastic collection of unusual islands. It's made me want to explore the world even more.
I completely agree. It's a reminder of how much we still have to discover and learn about our planet. Thanks for joining us on this geographical adventure. This has been Tech Bytes and News. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the fascinating story behind the PlayStation 2's backwards compatibility, as told by the engineer who made it happen, Tetsuya Ida. Get ready for a technical deep dive.
I'm pumped. Backwards compatibility isn't something you just throw into a console. It's a massive undertaking. What were the initial challenges Ida faced?
Right. Ida joined Sony in 1996, practically a newbie. Initially, his tasks were far removed from the PS2 project. He started with video converters, then worked on various components, gaining experience. But then, boom, he's tasked with PS1 backwards compatibility for the PS2. Crazy, right?
Absolutely. So they initially planned to use the PS1's main processor as an I/O processor for the PS2, but that meant emulating the rest of the PS1 hardware, a huge task. What part did he tackle first?
Initially, he and another engineer were assigned to emulate the PS1's SPU, the sound hardware. They even secluded themselves in a windowless room. But then, a twist.
A twist? Oh, I'm hooked.
The PS1 sound chip ended up being included in the PS2's design. All their work on the SPU emulator was suddenly useless. Talk about a setback.
Wow, that's brutal. So what happened next? Did they get reassigned to something else?
Even more unexpectedly, IDA was then tasked with emulating the PS1's GPU, the graphics processor. The original engineer had left the company, so it fell to him. He had to learn a whole new area.
That's incredible. Did he have any prior experience with graphics programming? That's a huge jump from sound.
Not really. But he saw emulators as converters, translating commands from the old processor to the new one. He had a framework to build on, thankfully, but it was still a monumental task. The first game he got running was Ridge Racer, but it was far from perfect. The Race Queen was a mosaic.
Haha, a mosaic race queen. That's a great anecdote. So how did this all culminate in the PS2 launch?
The big reveal was at the PlayStation Meeting 1999. IDA had to do a live demo, and he chose Crash Bandicoot. Warped, but there was a problem. The game sometimes froze.
Oh no! A live demo with a game that could freeze? That's high-stakes pressure.
Exactly. He and another engineer played through the game all night before the event to ensure it ran smoothly. He doesn't even remember much of the actual demo, because he was so focused on keeping the game running. But it worked.
That's a testament to his dedication and skill under pressure. So the PS2 launched with near-complete PS1 backwards compatibility?
Almost. There were a few games that didn't work, but it was a huge success. IDA considers this his most important achievement, and it's easy to see why. It helped cement the PS2's success and popularized backwards compatibility in the console market. A true legacy.
It really is. It's a fascinating story of dedication, problem-solving, and a little bit of luck. Thanks for sharing this incredible story with us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a truly explosive story. The UK government ordering Apple to create a backdoor into its users' encrypted data. It's a massive privacy showdown, folks.
A backdoor? That sounds incredibly invasive. So, what exactly is the UK demanding from Apple?
Exactly. They're not just asking for help with a specific case. They want blanket access, universal access, to all encrypted iCloud backups worldwide. Think about that for a second. Every photo, every message, every document, potentially accessible to the UK government.
That's a complete violation of user privacy and trust, isn't it? And what's Apple's response? Are they complying?
Well, not so fast. The article doesn't explicitly state Apple's official response, but the implications are huge. This order sets a dangerous precedent. If Apple complies, it breaks its core privacy pledge to users. If they refuse, they face potential legal battles and could even be penalized. It's a no-win situation, really.
This is unprecedented, right? No other major democracy has demanded something like this before.
That's precisely what makes this so alarming. The article highlights that there's no known precedent in major democracies for such a sweeping demand. It's a significant escalation in the ongoing tension between governments and tech companies over data privacy.
It's a slippery slope, isn't it? Once you create a backdoor, it's not just the UK that could exploit it. Other governments, even malicious actors, could potentially gain access.
Absolutely. That's the core argument against backdoors. The security of the system is compromised, and the potential for misuse is enormous. It's a classic security trade-off with potentially devastating consequences. This isn't just about the UK. It's about the global implications for digital security and privacy.
So what's the likely outcome here? A legal battle? A compromise? It's hard to predict, isn't it?
It's incredibly difficult to predict. A protracted legal battle seems likely. The stakes are incredibly high for both Apple and the UK government. This could set a precedent that impacts how governments worldwide approach data privacy and encryption. It's a story we'll be following closely.
Indeed, this is a critical moment for the future of online privacy. Thanks for breaking down this complex issue for us.
My pleasure. And to our listeners, thank you for tuning in to Tech Bytes and News. We'll keep you updated on this developing story. Have a great day and stay informed.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating GitHub project, Sort_Memories. It's a Python-based application designed to, get this, sort your photos based on who's in them. Pretty cool, right?
That sounds amazing. I'm always drowning in a sea of pictures. So how does this actually work? Is it magic, or is there some clever tech behind it?
No magic involved, thankfully. It leverages the power of face recognition. You first upload sample images of your favorite people. You know, the ones you want to easily find in your photos. Then, you upload your group photos, and the program uses face recognition to identify who's in each picture and sorts them accordingly. It's all about efficient image sorting.
I see. So it's like a super-powered photo album organizer? What libraries does it use? I'm guessing something like OpenCV?
Not quite OpenCV, but close. It uses face_recognition and DLIB. These libraries are specifically designed for face recognition tasks, making the process quite accurate. Plus, it's built on Flask, so it's a web application, making it super accessible.
Flask? That's a smart choice. Easy to deploy and scale, right? So, how does the user actually interact with it? Is there a fancy GUI or something?
It's not exactly a fancy GUI, more of a straightforward web interface. You upload your images through the browser to specific endpoints, one for the sample images and another for the group photos. The results are then saved to a local directory. Simple yet effective. It's all about functionality over flashy design.
Got it. So it's a command line interface, but web-based? That's interesting. What about the setup? Is it complicated?
Not at all. The instructions are pretty clear. You clone the repo, set up a virtual environment, standard Python practice, install the dependencies using pip, and then run the application. The README is well written, even for someone who's not super familiar with Python. It's very user-friendly.
That's reassuring. I'm always a bit wary of projects with complicated setup instructions. But this sounds pretty straightforward. What about the license? Is it open source?
Absolutely. It's licensed under the Apache 2.0 license, so it's completely open source. You can freely use, modify, and distribute it. A big plus for the community.
Excellent. This sounds like a really useful tool. I'm definitely going to check it out. Thanks for highlighting this project. It's a great example of how simple, well-executed code can solve a real-world problem.
My pleasure. And remember, folks, if you're struggling with a mountain of photos, this might just be the solution you've been searching for. Check out the link in the show notes. Thanks for tuning in to Tech Bytes and News. Have a great day, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Mozilla's fascinating journey with code signing, a topic that's both technically intricate and surprisingly engaging. Let's get started.
I'm really looking forward to this. The sheer scale of Mozilla's operations makes their code signing process a compelling case study. So, where did it all begin?
Right. It all started way back with Firefox 1.0, believe it or not. Initially, it was a pretty manual affair, involving detached GPG signatures and authenticode signing for Windows installers. Think a single Windows machine, a USB stick holding the precious keys, and a release engineer in Mountain View orchestrating the whole thing. Can you imagine?
A USB stick? That sounds incredibly risky. And what about the signing process itself? Was it straightforward?
Far from it. They used signCode.exe, which only accepted passphrases through a GUI dialog. So, they had to use an AutoIt script to automate the passphrase injection, a delicate dance of scripting and manual intervention, with the ever-present risk of mouse movements disrupting the process. It's almost comical in retrospect.
Comical, but also a testament to the ingenuity of those early engineers. How did they manage to improve upon this rather chaotic system?
The first major leap was automating the process with a makefile. This reduced human error significantly. Then, Chris Atlee's work in 2009 was truly game-changing. He slashed signing time from 8 hours to under 15 minutes by leveraging faster hardware, parallelization, and clever caching. A massive improvement.
That's incredible efficiency. But even with that speed up, there were still delays, right? How did they address that?
Exactly. They introduced AutoSign, which allowed the signing process to start ahead of time and wait for the build files to be ready. No more waiting for a release engineer to be available. A huge step towards automation.
Brilliant. And then they moved to Linux, which is a bit unexpected for signing Windows binaries.
Yes. In 2011, they moved to a secure Linux server using Mono's version of sign code. This allowed for on-demand signing, eliminating the need for multiple server transfers, a major shift in their infrastructure.
That's a bold move, and it seems to have paid off. What about other platforms like macOS? How did they handle signing.app bundles?
That was a longer journey. Initial attempts in 2010 failed, but they finally succeeded around 2012, though it required dedicated macOS signing servers. Not ideal, but a necessary step at the time.
It sounds like a constant evolution. What about their current system? What tools are they using now?
Their current system is built around Task Cluster, Autograph, and various other tools like OSSL Sign Code, WinSign, and Apple Co-Design. Autograph, in particular, is a significant improvement, using HSMs for key management and only transferring hashes for signing, saving a tremendous amount of network traffic. It's a sophisticated and secure system.
Impressive. So, from a manual process with USB sticks to a sophisticated, automated system leveraging HSMs and cloud services. What a transformation.
Absolutely. It's a testament to the dedication and ingenuity of the engineers at Mozilla. They've not only secured their software, but also streamlined the process to an incredible degree. And it's still evolving, with ongoing efforts to further improve security and efficiency. Thanks for joining us on Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating paper. Value-based deep RL scales predictably. It's a game changer, really. The core idea is that we can actually predict how well reinforcement learning algorithms will perform with more data or compute, something that's been a major challenge.
Predictable scaling in deep reinforcement learning? That's huge. I mean, usually, throwing more data or compute at a problem doesn't guarantee better results, right? It often leads to unpredictable outcomes, or even worse performance. So what's the secret sauce here?
Exactly. The paper focuses on value-based off-policy RL methods, algorithms like SAC, BRO, and PQL. They've found that the performance improvement follows a predictable Pareto frontier, controlled by something called the updates to data, UTD, ratio. Think of it like this. You have a limited budget, you can spend it on more data or more compute. This paper shows how to optimally allocate that budget.
So the UTD ratio acts as a kind of scaling knob. If we understand this ratio, we can predict how much more data we need for a given performance increase if we increase compute, or vice versa. That's incredibly elegant.
Precisely. They've developed a method to estimate this Pareto frontier. This allows them to predict data needs given more compute, and compute needs given more data, for a target performance level. It's not just about getting better results. It's about knowing how to get better results efficiently.
But isn't there a risk of overfitting or plasticity loss in RL? These are common issues that make scaling unpredictable. How do they address that?
That's a great point. They tackle that by first estimating predictable relationships between hyperparameters. This allows them to manage the effects of overfitting and plasticity loss, which are often the culprits behind unpredictable scaling behavior. It's a clever way to control the model's behavior during training.
So they're essentially building a model of the model's scaling behavior? Meta-learning, almost? This is really pushing the boundaries of what's possible in RL. They validated this on various benchmarks, right?
Exactly. They validated their approach using DeepMind Control, OpenAI Gym, and Isaac Gym, extrapolating to higher levels of data, compute, budget, or performance. The results are quite compelling, showing a high degree of predictability across different environments and algorithms. It's a significant step towards making deep RL more reliable and efficient.
This is truly groundbreaking work. The ability to predict scaling behavior opens up a whole new world of possibilities for optimizing RL training. Imagine the implications for resource allocation and algorithm design.
Absolutely. It's a major step forward in making deep reinforcement learning more practical and accessible. This research has the potential to significantly impact various fields that rely on RL, from robotics to game playing. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of predictable scaling in deep reinforcement learning. Goodbye, and until next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating paper. Turner, Bird, Eratosthenes, an eternal burning thread. It's all about the sieve of Eratosthenes, but with a functional programming twist. Exciting stuff.
I'm really looking forward to this. The sieve of Eratosthenes is a classic algorithm, but what makes this paper so special?
It's not just about the sieve itself. It's about how different functional programming approaches, particularly those championed by David Turner, tackle the problem. Turner's initial one-line sieve, while elegant, isn't a true Eratosthenes implementation. It's more of a trial division.
Trial division? So it checks every number for divisibility, not just multiples of previously found primes? That's less efficient, right?
Exactly. Melissa O'Neill's work highlights this inefficiency and presents a genuine functional sieve using priority queues. Much more efficient. But then Richard Bird comes along with a purely list-based, circular implementation. Ingenious!
A circular implementation? That sounds complex. How does that even work?
That's where the real fun begins. Bird's algorithm cleverly uses recursion and list manipulation to achieve the same result without priority queues. The paper then delves into proving the correctness and productivity of Bird's circular sieve. It's a challenge problem for Turner's concept of total functional programming, which aims to eliminate the possibility of non-termination.
Wow, that's a lot to unpack. So the core issue is proving that Bird's circular sieve, which is recursive and deals with infinite lists, will always produce results and not get stuck in an infinite loop?
Precisely. And that's where the paper presents a rigorous proof using the Approx lemma and Bertrand's postulate. It's a deep dive into mathematical logic and functional programming theory. It's not for the faint of heart, but incredibly rewarding.
So the paper essentially corrects a flaw in Bird's textbook, Thinking Functionally with Haskell, by providing a complete and accurate proof of his circular sieve algorithm?
Yes, and it also explores the historical context of the trial division algorithm, tracing its origins back to McElroy's work and its subsequent popularization by Turner, Kahn, and McQueen. It's a rich tapestry of algorithmic history and modern functional programming techniques.
I see. It's interesting how this paper connects the past with the present, showing how even seemingly simple algorithms like the sieve of Eratosthenes can lead to complex and fascinating research in functional programming. It also highlights the importance of rigorous proofs, especially when dealing with infinite data structures.
Absolutely. The paper beautifully illustrates the elegance and power of functional programming, but also the challenges involved in proving the correctness of such elegant, recursive algorithms. It's a testament to the enduring legacy of David Turner and Richard Bird in the field.
This has been a truly insightful discussion. Thanks for breaking down this complex paper for us.
My pleasure. And thank you to our listeners for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of functional programming and the eternal burning thread of the sieve of Eratosthenes. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into Expense Owl, a super simple expense tracker built with a really nice UI. It's designed for home lab use, but the simplicity is appealing, wouldn't you say?
Absolutely. The description emphasizes its speed and ease of use, which is a refreshing change from some of the more bloated expense trackers out there. It sounds like a minimalist's dream. What's the core functionality, though? I'm curious about the tech stack, too.
Right. So at its heart, Expense Owl is all about quick expense entry. You just pop in the amount, category, and optionally a name and date. It uses a JSON file for storage. Super straightforward. The tech stack is pretty lean. Go for the backend. Chart, JS, and plain HTML, CSS, and JavaScript for the front end. No fancy databases or frameworks. Just pure efficiency.
I see. So it's basically a lightweight, self-contained system. That's clever. How does the visualization work? The README mentions pie charts and tables.
Yeah, the visualization is really intuitive. You get a monthly pie chart showing your spending breakdown by category. You can even click categories to temporarily remove them from the chart for a clearer view of the rest. Then there's a table view for a detailed chronological list of expenses, allowing for easy deletion. It's all very clean and mobile-friendly, too.
That's a nice touch, the interactive pie chart. Makes it easy to spot spending trends. What about installation? Does it require a lot of setup?
Nope, installation is a breeze. You can use Go Install, Docker, or build it from source. The Docker image is particularly convenient. It even supports persistent storage and lets you customize categories and currency via environment variables. It's really well thought out for different deployment scenarios.
That's impressive. The fact that it's available as a PWA is also a great addition, making it accessible across devices. But I noticed it mentions no authentication. Isn't that a security concern?
You're right to point that out. The lack of authentication is a significant limitation. It explicitly states it's intended for home lab use, implying a trusted environment. For a production setting, you definitely need to add authentication and potentially more robust security measures. It's a trade-off for simplicity, I guess.
Definitely. A trade-off between ease of use and security. It's a good example of how design choices impact different aspects of a project. So it has a CLI too, right? For more automated tasks?
Exactly. The CLI allows for both server and client-side operations. The client mode lets you add expenses via the command line, which could be handy for scripting or automation. And the REST API provides even more flexibility for integration with other tools.
That's a powerful feature for those who prefer command line interfaces or want to integrate it into their workflows. It seems like a very well-designed project, despite its simplicity. The developer clearly prioritized ease of use and a clean design.
Precisely. It's a testament to how much you can achieve with a focused approach and a well-chosen tech stack. The developer's clear intention to keep it simple and focused on core functionality shines through. It's a great example of a project that solves a specific need effectively. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into Expense Owl. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating project, Ghostwriter, a system that lets you interact with large language models directly on your remarkable 2 e-reader. It's incredibly cool.
Whoa, an e-reader interacting with LLMs? That sounds futuristic. What's the core idea behind Ghostwriter?
Essentially, it's a bridge between your handwritten notes on the remarkable 2 and powerful AI models like ChatGPT, Claude, and even Gemini. You write a prompt, tap a corner of the screen, and Ghostwriter sends your input to the chosen LLM, then displays the response right on your device. It's all about exploring the unique interaction possibilities of handwriting and screen-based feedback.
Amazing! So how does the setup work? I'm assuming some API keys are involved?
You bet. You need API keys for the LLM you want to use. OpenAI, Anthropic, Google, and you set those as environment variables on the Remarkable itself. Then, you transfer the Ghostwriter binary to the device via SCP, make it executable, and you're ready to go. It's all detailed in the GitHub repo.
And how do you actually use it? Is it just a simple command line interface?
It's more intuitive than that, actually. You write your prompt, then a simple tap in the upper right corner triggers the LLM interaction. The processing is shown with a visual cue, and then the response, whether text or a drawing, appears on the screen. There's also a text assist mode that uses a virtual keyboard for responses.
That's clever. The GitHub repo mentions some early challenges. What were some of the initial hurdles?
Oh, there were a few. Early on, drawing responses directly on the screen was problematic. The Remarkable would sometimes freak out when trying to render complex SVGs converted from the LLM's output. They had to work around that. Getting the gesture recognition and status display working smoothly was also a bit of a journey.
I see. So it's been an iterative process. What are some of the more recent developments?
A lot. They've added support for multiple LLMs, including Claude from Anthropic and Google's Gemini. They've also improved the codebase significantly, making it more modular and easier to maintain. And they've introduced a really cool feature, the ability to use tools within the prompts. This allows the LLM to generate different types of outputs, like text, SVGs, or even trigger external scripts.
That's a huge leap forward. What about the evaluation process? How do they assess the system's performance?
They've started building an evaluation system. They capture input and output, and they're working on tools to compare results across different prompts and LLMs. They even mention the possibility of using another AI to judge the output quality. A judge bot, if you will.
A judge bot? That's hilarious. What are some of the future plans for Ghostwriter?
Well, there are many exciting ideas. They want to improve usability, add more tools, explore conversation modes, and even support local LLMs. The possibilities are really endless. Imagine using this to generate diagrams, manage your to-do list, or even send emails, all directly from your Remarkable 2.
This is truly a remarkable project, pun intended. It showcases the potential for seamless integration between handwriting, LLMs, and everyday devices. Thanks for sharing this with us.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating piece about VS Code's SSH agent, or rather, the author's concerns about its security implications. It's titled, VS Code's SSH agent is bananas, and it's a real eye-opener. Intriguing, right?
Bananas? Sounds dramatic. I'm curious. What's the core issue?
The author, Thomas Plitakek, points out that while VS Code's remote editing via SSH is convenient, especially with the rise of LLMs generating code, the way it achieves this is concerning. He draws a comparison to Emacs's Tramp system, a much more lightweight and secure approach.
So what's wrong with VS Code's approach? Is it just less efficient?
No, it's far more serious than inefficiency. Unlike Tramp, which uses existing SSH capabilities, VS Code deploys a full-blown agent. This agent, downloaded and run on the remote server, has extensive permissions. It can wander the file system, edit files, launch shell processes, and even persist itself. That's a huge security risk.
Whoa, that sounds like a massive attack surface. Essentially, it's giving a potentially malicious piece of software extensive control over the remote system?
Precisely. The author uses the analogy of a murid tool, something that burrows and nests, to describe the agent's behavior. He expresses serious reservations about using this for development servers, and rightly so. Imagine the implications if this were used on a production system during an incident.
I see. So the author's main point is that VS Code's SSH agent is overly privileged and poses a significant security vulnerability, unlike the more contained approach of Emacs Tramp?
Exactly. He highlights the contrast between the two approaches. Tramp leverages existing SSH infrastructure, while VS Code installs a separate agent with broad permissions. This difference is crucial from a security perspective. It's a bit like comparing a well-maintained, locked door to a wide-open window.
But isn't this a known issue? Hasn't Microsoft addressed this? I mean, it's a pretty big deal.
That's a great question. The article doesn't explicitly state whether Microsoft is aware of the issue or has plans to address it. However, the author's strong concerns suggest that this might not be widely known or addressed yet. It's definitely something that warrants further investigation.
Right, so the takeaway is that while VS Code's remote editing is convenient, developers should be acutely aware of the security implications of its SSH agent. Perhaps using alternative methods, or at least exercising extreme caution, is advisable, especially in sensitive environments.
Absolutely. The author's point is not to discourage the use of VS Code's remote editing capabilities, but to highlight the potential risks and encourage a more informed approach. It's a call for responsible usage, and perhaps a push for improved security measures from Microsoft. Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating project, a Game Boy emulator built entirely in Ruby. It's called Ruby Boy, and it's a real gem, pun intended.
A Game Boy emulator in Ruby? That's incredibly ambitious. I'm intrigued. What makes this project so special?
Well, for starters, it's a fully functional emulator, running games like Pokemon and Puyo Puyo. But the real kicker? It runs in your browser thanks to WebAssembly. Imagine playing classic Game Boy games directly in your browser, all powered by Ruby.
That's amazing. So how did the developer, Saki, pull this off? What were some of the key challenges?
The architecture is quite complex. He had to emulate the Game Boy's hardware, including the CPU, PPU, memory management, and more. He used a class structure mirroring the Game Boy's components: console, LCD, bus, CPU, and so on. Each class handles a specific aspect of the emulation. The main loop is elegantly simple. Fetch instructions, execute them, and update the PPU, timer, and sound.
That sounds straightforward enough, but I imagine the devil's in the details. What were some of the hurdles he encountered?
Oh, plenty. He ran into issues with flag calculations in the CPU, specifically with the carry flag in certain instructions. He also had problems with the pop AF instruction, initially failing to zero out the lower 4 bits of the F register. Debugging this kind of low-level stuff must have been a nightmare.
Absolutely. And I bet performance was a major concern, right? Running a Game Boy emulator is computationally intensive.
You're right. Initially, the emulator was painfully slow. So, Saki embarked on a serious optimization journey. He used StackProf and Heap Profiler to identify bottlenecks. He started with the usual suspects: enabling YJIT, avoiding unnecessary hash creation, and moving calculations outside loops.
Classic optimization techniques. Did those alone solve the performance issues?
Partially. Upgrading to Ruby 3.3 provided a massive performance boost thanks to YJIT improvements. But he still had to tackle GC issues. He optimized the CPU instruction handling to reduce hash creation, and that significantly reduced garbage collection overhead. He even went as far as pre-calculating address mappings to eliminate conditional branching.
Wow, that's impressive. Pre-calculating address mappings is a clever trick. I'm guessing that significantly reduced the number of comparisons needed.
Exactly. It's a technique borrowed from other emulators, and it paid off handsomely. He also optimized the PPU rendering by caching tile data, tile map data, and palette data. He even changed the pixel format for faster rendering, ultimately achieving a remarkable speedup.
So the final result is a surprisingly performant emulator running entirely in Ruby, even in the browser via WebAssembly. That's a testament to the developer's skill and the power of optimization.
Absolutely, it's a fantastic achievement. The project showcases not only the capabilities of Ruby, but also the dedication and ingenuity of the developer. And the best part? You can try it yourself. The demo is available online. Go check out Saki's Ruby Boy. It's a must-see for any Ruby enthusiast or retro gaming fan.
I definitely will. Thanks for highlighting this incredible project. It's inspiring to see what's possible with Ruby.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating blog post about visual explanations in mathematics. It's a really insightful piece, and I think you'll find it as captivating as I did. Let's get started.
Sounds great. I'm always up for a discussion about improving the way we communicate complex ideas, especially in math. What's the core argument of this blog post?
The main idea is that mathematical explanations can be significantly improved through visualization. The author argues that equations, while precise, often fail to elucidate concepts effectively. They can even obfuscate things. Think about it. How many times have you stared at an equation, completely lost?
Oh, way too many times. I totally get that. So how does the author suggest we improve this?
The author uses several examples of visually enhanced mathematical explanations. One standout is Oliver Byrne's visually stunning version of Euclid's Elements. Byrne cleverly integrated geometric drawings with text, making the material far more accessible. It's a beautiful example of visual explanation.
I see. Interesting. So it's not just about pretty pictures, but about actually making the math clearer?
Exactly. The author references Edward Tufte, a prominent figure in data visualization who emphasizes the importance of visual explanations that elucidate, not just illustrate. The post then showcases various examples, annotated equations, color-coded representations, even pictograms, all designed to enhance understanding.
That's a really interesting point. But isn't there a risk that these visual aids could oversimplify complex concepts, potentially leading to inaccuracies?
That's a valid concern. The author acknowledges this, mentioning the legend lookup problem where color coding can be confusing, especially for those with color blindness. However, the examples presented generally prioritize clarity and avoid oversimplification. Direct annotation, for instance, is highlighted as a superior method.
Got it. So the key is finding a balance between visual appeal and accuracy. What other methods are discussed besides annotation and color coding?
The author also discusses the use of code as a visual representation. He points out that for some, code is a more intuitive way to understand mathematical concepts than symbolic equations. Randall Munroe's work is cited as a great example of this approach.
That's a really cool idea. I hadn't thought of code as a visual aid before, but it makes sense. It's a direct, interactive way to explore the math. What's the overall takeaway from the blog post?
The author concludes that while we have many tools for writing mathematics, LaTeX, Markdown, Jupyter Notebooks, a truly seamless integration of symbolic equations, visual annotations, and runnable code is still needed. But the examples provided show that we can already do much better than we currently do.
It's a call to action, then, to explore and utilize these visual methods more effectively. A really thought-provoking piece. Thanks for summarizing it.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating blog post from Pulse AI. Why LLMs Suck at OCR. It's a real eye-opener, folks. Get ready.
I'm all ears. I've heard whispers about LLMs struggling with OCR, but this sounds like a detailed breakdown. What's the core argument?
Exactly. The core argument is that while LLMs are amazing at text generation and summarization, they're surprisingly bad at optical character recognition, especially with complex documents. They prioritize semantic understanding over precise character recognition, leading to all sorts of errors. It's a big problem.
So how do these LLMs even see an image? I mean, it's not like they have eyes, right?
Right. They don't have eyes. They use something called high-dimensional embeddings. Think of it as creating an abstract representation of the image, focusing on the meaning rather than the precise details. This process is inherently lossy. Information gets lost in translation. Imagine trying to describe a painting using only a few words. You'd lose a lot of the nuance, right?
I see. So that loss of detail is what causes the problems with things like tables and unusual fonts? The LLM just misses crucial information?
Precisely. They might understand that a cell contains a number, but they might miss the decimal point, commas, or even the font style indicating special meaning. The attention mechanism, a key part of how LLMs work, also has blind spots. It divides the image into fixed-size patches, which can split characters, and it loses fine-grained spatial relationships. It's a recipe for disaster.
That's concerning. The blog post mentions hallucinations. What are those in this context?
Yeah, that's a big one. Because LLMs work probabilistically, predicting the next token based on probabilities, they can make educated guesses that seem plausible but are completely wrong. They might substitute similar-looking characters, like RN for M or L for 1. These subtle changes can drastically alter the meaning of a document. It's terrifying.
So it's not just about missing information, it's about actively creating incorrect information? That's a whole different level of failure.
Exactly. And it's not just theoretical. The blog gives real-world examples of catastrophic failures in finance and healthcare. Decimal point shifts in currency amounts, medical dosage misinterpretations. These are life-altering errors. It's scary stuff.
Wow. The blog also mentions prompt injection. Is that a security vulnerability?
Absolutely. They found that specific text patterns in a PDF can trick the LLM into ignoring its original instructions and revealing internal information, or even complying with malicious requests. It's a serious security risk. It's a huge problem.
So what's the takeaway? Are LLMs completely useless for OCR?
Not completely useless, but definitely not a silver bullet. The blog argues that current LLMs are fundamentally limited for complex OCR tasks. Pulse AI is building a custom solution, combining traditional computer vision techniques with vision transformers to overcome these limitations. It's a complex problem requiring a sophisticated solution.
It sounds like a fascinating area of research. Thanks for breaking this down for us. This is definitely something to keep an eye on.
You're welcome. And that's all the time we have for today. Thanks for tuning in to Tech Bytes and News. We'll see you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating blog post about the different coding hats a programmer might wear. It's all about adapting your coding style to the situation, not just aiming for some mythical perfect code. Exciting, right?
Absolutely. So this isn't about good versus bad code, but about context? I'm intrigued.
Exactly. The author draws a parallel to Edward de Bono's 6 thinking hats, suggesting we adopt different approaches depending on the task. He outlines 5 coding hats: Captain, Scrappy, MacGyver, Chef, and Teacher. Each one represents a distinct coding philosophy.
The captain's hat sounds like the traditional, careful approach. Thorough testing, small commits, code reviews, the whole shebang. Safe and reliable, right?
Precisely. Think mission-critical systems. You wouldn't want a single bug to crash millions of systems, like that CrowdStrike incident. Safety first.
I see. And the Scrappy hat is the opposite. Quick and dirty prototypes, minimal testing, just get something working. Perfect for hackathons or early-stage startups.
Spot on. It's about speed and iteration. Minimum viable product, Get it done, refine later.
Then there's the MacGyver hat. The get-it-done-no-matter-what approach. Messy, but effective. Sounds like a fun one.
Oh yeah, it's all about experimentation. Try 5 different approaches quickly, even if the code is a mess. Refine later if it works. It's about proving a concept.
Interesting. So, the chef's hat is about code elegance and presentation? Making it beautiful.
Yes, it's about making the code look beautiful, even if it's already functional. A bit of polishing, but the author cautions against overusing it. Sometimes, it's just polishing for its own sake.
I agree, it's easy to get caught up in that. And finally, the teacher's hat, focusing on clarity and communication, not necessarily efficiency. Great for tutorials and example code.
Exactly. Prioritizing understanding over optimal performance. Makes sense. The overall message is to be mindful of the context and choose the right hat for the job. It's not about one right way to code.
I think that's a really valuable point. It's about flexibility and adaptability. A great reminder for all of us.
Absolutely. It's about being deliberate about your approach and not getting stuck in a single mindset. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this discussion on the 5 coding hats. Bye for now.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating piece titled Repost: Science is a Strong Link Problem, exploring the crucial distinction between strong link and weak link problems. A game changer, really.
I'm eager to hear this. The title itself is intriguing. What's the core argument?
The author argues that many problems, especially in science, are mistakenly treated as weak link problems when they're actually strong link ones. A weak link problem, like food safety, hinges on the worst element. One bad apple spoils the bunch. You need to eliminate the worst to ensure safety.
Got it. So a strong link problem is the opposite?
Precisely. In a strong link problem, like music or Olympic success, the overall quality depends on the best elements. The bad stuff is largely irrelevant. You focus on amplifying the best, not eliminating the worst.
That's a powerful distinction. The article uses some compelling examples, doesn't it? Like the FDA regulating food versus regulating music?
Exactly. An FDA for music would be disastrous. It would stifle creativity and innovation by focusing on eliminating bad music, instead of letting the good music rise to the top. It's a brilliant analogy.
I see. But isn't there a risk in ignoring the bad completely? Could that lead to misinformation or unethical practices going unchecked?
That's a valid concern. The author acknowledges that bad science can temporarily mislead, but ultimately, better ideas tend to prevail. It's a long-term perspective. Think of it like natural selection. The fittest ideas survive.
Interesting. So the article claims that science is often treated as a weak link problem, with things like rigorous peer review intended to eliminate bad research. But this is counterproductive, right?
Yes. The author argues that this approach, while effective for weak link problems, stifles innovation in science. A strong link problem, peer review, grant applications. They all create barriers to entry for novel, risky, or interdisciplinary research.
So we're inadvertently hindering progress by focusing on preventing bad science instead of fostering good science? That's a pretty bold claim.
It is, and the author supports it with evidence. They cite numerous Nobel laureates who've stated that their groundbreaking work would be impossible to replicate in today's hyper-competitive, risk-averse scientific environment.
Wow. That's quite a damning indictment of the current system. The article suggests that this weak link approach stems from fear and a focus on maintaining status within the scientific hierarchy.
Precisely. The fear of failure, the intense competition for funding and recognition, pushes scientists towards low-risk projects, hindering groundbreaking discoveries. The emphasis on status leads to gatekeeping, preventing truly innovative work from emerging.
It's a really thought-provoking piece. It makes you question the effectiveness of current practices in science. The author concludes by suggesting that we need to shift our focus from preventing bad science to promoting good science.
Absolutely. It's a call for a paradigm shift, a move away from the fear-based, status-driven approach to a more open, risk-tolerant environment that prioritizes groundbreaking discoveries. It's a powerful message, and one that deserves serious consideration.
Definitely. Thanks for summarizing this insightful article. It's given me a lot to think about.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating discussion about the hidden space hogs on Unix systems, those pesky .directories. Specifically, we're looking at a blog post highlighting the problems caused by applications storing massive caches in hidden directories like .cache and .local. It's a real space-saving conundrum.
Exactly. So many programs are guilty of this, right? They just dump gigabytes into these hidden folders, leaving users completely clueless about where their disk space is vanishing. It's like a digital black hole.
Precisely. The author points out that even if a program does use a standard location like ~/.cache, it's still a problem. Most users don't routinely check these hidden directories. Standard do commands often miss them, especially if users aren't familiar with advanced sorting techniques.
Yeah, I've seen that firsthand. I usually just do a doesh from my home directory. That completely misses all the hidden stuff. It's not intuitive at all. It's like searching for a needle in a haystack, but the haystack is invisible.
Haha, I see your point. The author even mentions that many GUI file browsers, like Cinnamon's files, omit .directories by default. It's not exactly user-friendly. It's a usability nightmare.
Absolutely. And the blog post highlights a particularly challenging environment. A shared file server with graduate students doing AI research. These folks are dealing with massive data sets and software packages, making the hidden cache problem even more critical. Hundreds of gigabytes disappearing into the ether. That's terrifying.
You're right. The scale of the problem is amplified in that context. The author suggests a simple solution. Program developers should store large caches in clearly visible directories. This would make it much easier for users to monitor disk usage and manage their storage space. It's a pretty straightforward fix, really.
It seems obvious, but it's not happening. I wonder why developers persist with this practice. Is it just laziness, or is there some technical reason I'm missing? Maybe some legacy compatibility issue?
That's a great question. I don't have a definitive answer, but it could be a combination of factors. Perhaps some developers are unaware of the problem, or maybe they prioritize other aspects of development over user experience in this specific area. It's definitely something that needs more attention.
Definitely. The blog post makes a strong case for better practices. It's not just about disk space, it's about user understanding and control. It's about transparency and avoiding frustration.
Precisely. And the author's suggestion about disk space usage tools explicitly showing these hidden directories is also crucial. It's a simple change that could make a huge difference. We need better tools and better practices.
Totally agree. Thanks for bringing this to our attention. It's a problem that affects many of us, and it's great to see someone highlighting it and suggesting solutions.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating GitHub project. AI fanatics attempt to recreate Unreal Engine's nanite technology in Three.js. It's a really ambitious undertaking, isn't it?
Absolutely. Unreal Engine's nanite is a game changer for handling massive polygon counts in real time. To try and replicate that level of efficiency in a JavaScript library like Three.js, that's impressive.
Exactly. The project's description is pretty upfront. It's a work in progress, and the code is admittedly a bit messy right now. But the core concept is brilliant. They're breaking down the problem into manageable steps.
I see. So what are those steps? From what I gather, it involves meshlet creation, clustering, merging, and simplification, all using external libraries like METS and Mesh Optimizer, right?
Yeah, pretty much. First, they meshletize the original object, creating smaller, manageable meshlets. Then, using METS, a graph partitioning library, they group these adjacent meshlets. After that, Mesh Optimizer comes in to merge these grouped meshlets, sharing vertices for optimization. Finally, they simplify the mesh using Mesh Optimizer's Garland algorithm, aiming for a maximum of 128 triangles per meshlet. It's a multi-stage process, cleverly leveraging existing tools.
That's a clever approach. Using established libraries like METS and Mesh Optimizer is smart. It leverages existing, well-tested solutions. But doesn't this simplification process potentially lead to significant loss of detail, especially at closer viewing distances?
That's a valid concern. The project acknowledges this. The simplification is a key part of achieving the dynamic LOD, level of detail. The goal isn't perfect fidelity at all distances, but rather a smart trade-off between detail and performance. The screenshots show a pretty impressive result, considering the limitations.
The GIFs on the GitHub page are particularly compelling. They demonstrate the dynamic LOD switching quite effectively. It seems like the next steps involve more testing and potentially streaming geometry directly to the GPU for even better performance, right?
Precisely. The author explicitly mentions that as a TODO item. Streaming geometry to the GPU would be a huge performance boost, especially for extremely complex models. It's a challenging task, but it would take this project to the next level.
And the project has already garnered quite a bit of attention, with over 364 stars on GitHub. That speaks volumes about the interest in this approach to real-time rendering of complex 3D models.
Absolutely. It's a testament to the ingenuity and the potential of this project. It's a great example of how open-source collaboration can push the boundaries of what's possible in web-based 3D graphics. It's still early days, but the potential is enormous. It's really exciting to see this kind of innovation happening in the Three.js ecosystem.
I agree. It's a fantastic project to follow. Thanks for highlighting it.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article. Stop using zip codes for geospatial analysis. It's a real eye-opener, folks. Get ready.
I'm all ears. Zip codes? What's the big deal? I mean, they seem pretty straightforward.
That's exactly the problem. They seem simple, but they're a surprisingly inaccurate tool for serious geospatial analysis. The article points out that zip codes represent postal delivery routes, not actual geographic areas. They can overlap, be incomplete, or even be completely artificial constructs. Think about it. A zip code might cover a diverse range of neighborhoods, masking crucial variations in income, demographics, and even public health issues.
Whoa, that's a pretty big oversight. I never thought about it that way. So what are the consequences of using zip codes incorrectly?
Big ones. The article highlights the Flint water crisis as a prime example. Using zip codes to analyze lead levels masked the true extent of the problem, because the zip code boundaries didn't align with the city's water system. It's a chilling illustration of how inaccurate data can lead to disastrous consequences.
Yikes! So what's the alternative? Should we just give up on zip codes altogether?
Not at all. The article suggests several better approaches. One is using actual addresses and geocoding them to get precise latitude and longitude coordinates. This gives you much more granular data. Another is using census units like block groups or tracts, which provide more accurate geographic boundaries and associated demographic data. And finally, the article champions the use of spatial indexes like H3 or quad key, which are global, multi-resolution grid systems. These are super efficient for analysis and anonymization of sensitive data.
Those sound like significant improvements. But aren't census data and spatial indexes more complex to work with than simple zip codes?
That's a valid point. They do require a bit more technical expertise. However, the article mentions several tools and libraries like SendPy and Car2 that simplify the process. The payoff in terms of accuracy and insightful analysis far outweighs the initial learning curve, I think. Plus, the potential for better decision-making and avoiding costly mistakes is huge.
I see. Interesting. So the core message is that while zip codes might seem convenient, they're ultimately a flawed tool for serious geospatial analysis. We need to move towards more precise and accurate methods to avoid misleading conclusions and potentially harmful outcomes.
Exactly. The article really drives home the importance of using the right tools for the job. Using zip codes for anything beyond a quick, rough estimate is a recipe for disaster. It's all about choosing the appropriate spatial scale and understanding the limitations of your data. It's a crucial lesson for anyone working with geospatial data.
Absolutely. Thanks for breaking this down. This is definitely something I'll be thinking about next time I'm working with location data. This was a great discussion.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you found this discussion insightful and informative. Until next time, goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a quirky article from Sora News 24 about stations of despair in Tokyo. Specifically, Otsuki Station on the Chuo Rapid Line. Intriguing, right?
Totally. Stations of despair? Sounds like something out of a Japanese horror movie, but I'm guessing it's not quite that dramatic. What's the deal?
Exactly. It's not about the stations themselves being dangerous or unpleasant. It's about the location. The last stop on a line that runs through bustling areas like Shinjuku. People get drunk, miss their stop, and wake up in the middle of nowhere, in Otsuki, with no easy way home until morning.
Oh, I see. So it's the perfect storm of late-night revelry and inconvenient train schedules. Sounds like a recipe for a very long, cold night.
You got it. The article even features a reporter who went to Otsuki Station at night to experience it firsthand. He found it freezing cold. The station's waiting room closes at midnight, so he had to brave the streets.
Uh-oh. What did he find? Any late-night ramen shops or something?
Not really. Most places were closed early. He did find a Lawson convenience store with a tiny eat-in area, but it only had 3 seats. A bit of a struggle for a comfortable night, I'd say.
3 seats? That's brutal. So what was the best option he found?
Surprisingly, a Big Echo karaoke parlor. Some of their rural branches are basically little private karaoke shacks, open all night. He could rent one and just sleep on the sofa. Genius.
That's unexpectedly resourceful. I mean, who would have thought karaoke would be the solution to a station of despair problem? What about hotels?
There's a huge Toyoko Inn nearby, almost comically large for a town of only 20,000 people. The article suggests it might be there specifically to cater to those who end up stranded at Otsuki Station. But, of course, it might be fully booked during peak seasons.
That's a smart business model, actually. Capitalizing on misfortune. I guess the moral of the story is, plan your train rides carefully, especially after a night out, and maybe learn some karaoke.
Precisely. The article ends with a strong recommendation to check train schedules before hitting the town. But if you do find yourself in Otsuki, at least you have options. Thanks for joining us on Tech Bytes and News. Have a great day, and remember to plan your trips wisely.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating study published in Nature. Children's arithmetic skills do not transfer between applied and academic mathematics. It's a real eye-opener.
I'm eager to hear this. So what's the core finding? Is it just about kids struggling with math, or is there something more nuanced?
Oh, it's much more nuanced than just kids struggling with math. The study shows a striking disconnect between how children use math in real-world situations and how they perform on standard school math tests. Think about it. A huge gap.
Interesting. So they're good at one but not the other? Like, what kind of real-world math are we talking about?
Exactly. They looked at children working in markets in India. These kids are incredibly adept at complex calculations involved in daily transactions, figuring out costs, change, dealing with unusual quantities, all mentally, often without any tools. Amazing, right?
Absolutely. But then what happens when they take a standard school math test?
That's where the disconnect comes in. Despite their amazing real-world skills, these same kids struggle significantly with abstract math problems presented in a school setting. The study used the Annual Status of Education Report, ASER, test, a standard Indian numeracy assessment. The results were disappointing.
So the skills don't transfer. Is it just a matter of test anxiety or something?
The researchers went to great lengths to rule out confounding factors like stress, lack of incentives, or even the format of the test. They ran multiple experiments, including using incentives, changing the test format, and even creating a simulated market setting for school children. The gap persisted.
Wow. That's pretty compelling evidence. But why is this happening? What's the mechanism?
That's the million-dollar question. The study suggests that the way math is taught in schools doesn't connect with the intuitive, practical math skills kids develop outside the classroom. The school-taught algorithms, while based on the same underlying principles, aren't effectively utilized by the kids who excel in real-world scenarios. It's a failure of pedagogy, essentially.
So the school system isn't bridging the gap between intuitive and formal math understanding? That's a serious problem.
Precisely. The study highlights the need for a more contextualized approach to math education, one that connects abstract concepts to real-world applications. They even cite other studies showing that integrating financial education into the curriculum can improve both math skills and overall school performance.
It makes you wonder how many other kids are similarly disadvantaged by this disconnect. It's not just about test scores. It's about limiting their future opportunities.
Exactly. This research has significant implications for educational policy and curriculum design. We need to find ways to make math more relevant and engaging for all students, building upon their existing intuitive understanding rather than treating it as something entirely separate.
This is a really important study. It highlights a critical flaw in our educational systems and offers a path towards improvement. Thanks for bringing this to our attention.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating discovery. Mysterious new radiation belts surrounding Earth, a consequence of a truly epic solar storm last year.
Wow, that sounds intense. So what exactly happened? I mean, we hear about solar storms, but new radiation belts? That's a big deal, right?
Absolutely. In May 2024, a massive solar storm hit Earth. So powerful, its effects were even felt deep in the ocean. It unleashed a torrent of solar particles, creating stunning auroras visible at unusually low latitudes. But the real surprise was the aftermath.
Right, the auroras. I remember seeing those amazing pictures. But what about these new radiation belts?
Yeah, the storm created two temporary radiation belts. One is made up of electrons, which we've seen before after powerful geomagnetic storms, but the other, this is the kicker, contained high-energy protons. That's never been observed before.
Never before? That's incredible. What makes this proton belt so significant?
Well, it's a completely new phenomenon. It challenges our understanding of how these belts form and behave. And it has implications for our satellites. High-energy particles in orbit can damage satellite electronics.
Oh, I see. So this is a potential hazard to our space-based technology? How long did these belts last?
That's exactly right. Surprisingly, these belts persisted for much longer than usual. 3 months? Most temporary belts disappear within weeks. Even more surprising, some of the proton belt might remain for over a year.
A year? That's a long time for a temporary phenomenon. What caused this unusual longevity?
That's what scientists are still investigating. Subsequent storms in June and August 2024 did diminish the belts, but a significant portion remains. The research was based on data from NASA's CIRBE CubeSat, which is pretty amazing in itself.
So what's the next step? Are scientists worried about the long-term effects of these belts?
Absolutely. The immediate hazard is still unquantified, but this discovery is crucial. Understanding how these belts form and their potential impact on satellites will help engineers develop better protection strategies for our technology. It's a game changer for space weather forecasting, you know?
It certainly is. This research highlights the power of solar storms and the need for continued monitoring of space weather. It's a reminder of how much we still have to learn about our own solar system.
Exactly. The research was published in the Journal of Geophysical Research, Space Physics, and it's definitely worth checking out for more details. This is a huge step forward in our understanding of space weather and its impact on Earth. Thanks for joining us on Tech Bytes and News.
Thanks for the update. It was a fascinating discussion. Until next time, folks.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating GitHub project, TRRE, or Transductive Regular Expressions. It's a prototype, so remember, not for production use just yet, but it's incredibly interesting.
Right, a prototype. I'm intrigued. What's the core idea behind TRRE? Is it just a fancier grep?
It's more than that. It extends regular expressions to make text editing more intuitive. Think of it as a way to define transformations directly within the regex itself, using a colon, to specify replacements. So, A replaces all instances of A with B. Simple, right? But it gets way more powerful than that.
Oh, I see. So instead of post-processing with groups, the transformation is embedded in the pattern itself. That's a neat approach. But how does it handle more complex scenarios? Like multiple replacements in one go?
Exactly. You can chain these transductive pairs. For example, CETA, O-T, transforms cat into dog, or even better, you can use parentheses for readability. Cat, sad-faced dog. It also supports deletion. X, smiley face removes X, and insertion. X inserts X. It's incredibly flexible.
That's pretty slick. And what about the usual regex features like alternation and repetition?
Those are fully supported. You can use the pipe for alternation, just like in standard regex. The star works for repetition, but with a twist. In scan mode, the default, you can omit the parentheses around the transductive pair when using the star. It's designed to be intuitive. But be careful.
Careful? What do you mean?
Yeah. The danger zone is using or plus on the right-hand side of the colon. That can lead to infinite loops. The project emphasizes this. Instead, use finite iterations if you need repeated generation.
Good point. That's a crucial warning for users. So what about performance? How does it compare to existing tools like SED?
The non-deterministic version is a bit slower than SED for simple tasks, but the deterministic version, TR_DFT, can significantly outperform SED on more complex operations, like case conversion across an entire text file. The project provides benchmarks showing this.
Interesting. And what's the underlying magic? How does it actually work?
It uses finite state transducers, FSTs, instead of the finite state automata, FSAs, used in regular expressions. FSTs handle input-output pairs, making the transformations possible. The project even includes a theoretical sketch of the proof of correspondence between TRRE expressions and their FST representations. It's quite technical, but fascinating.
Wow, that's deep. So it's a really interesting project, pushing the boundaries of regular expressions. It's still a prototype, but the potential is huge.
Absolutely. There's a lot of work still to be done. Full Unicode support, efficient range processing, and a stable DFT version are all on the TODO list, but it's a very promising project. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into TRRE. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating evolution of telephone annunciators, a journey from pencil thumping to the familiar ring we all know and love. It's a story of ingenuity and innovation.
Absolutely. I'm particularly intrigued by the early methods. Yelling, "Ahoy!" That's quite a picture, isn't it? Imagine the sheer volume needed to be heard over distance.
Exactly. And then there's the pencil thumping method. Crude, but effective. Though, as Watson pointed out, providing a pencil with every telephone would be, expensive. Not to mention the potential damage to the delicate telephone diaphragm.
So Watson's hammer was a significant improvement, right? A more controlled way to signal. I'm curious about the mechanics of that.
Precisely. He cleverly positioned the hammer to strike the diaphragm's side, minimizing damage. A simple, yet brilliant solution. It's a testament to his practical approach to problem solving. Think of it. A mechanical solution in a world rapidly embracing electricity.
Amazing. But then came the buzzer, which, surprisingly, wasn't actually a buzzer in the traditional sense. It was more of a voltage generator, right? A bit misleading in its name, I'd say.
You're spot on. It generated high voltage to buzz the receiver, creating a loud, albeit somewhat unpleasant sound. Watson himself compared it to a grating car horn. Not exactly a pleasant auditory experience. It's interesting how even early on, user experience was a consideration, even if not always successfully implemented.
I see. And then the magneto generator came along, offering a more efficient and reliable solution. A significant leap forward in terms of both sound and practicality.
Absolutely. The magneto was a game changer. Generating 80 volts AC, it provided a much clearer and louder signal. It's fascinating how this technology, initially used for signaling, became the standard for ringing up a telephone. It's a testament to the adaptability of technology.
But the story doesn't end there, does it? The actual bell, the ringer, was still a challenge.
No, it certainly didn't. Watson's invention of the telephone bell was another monumental achievement. It wasn't easy. He faced numerous setbacks and complaints before perfecting a reliable design. The fact that his design, a polarized ringer, remains largely unchanged to this day is a testament to his genius.
It's incredible to think about the evolution from a simple, "ahoy," to the sophisticated ringing systems we have today, all starting with such rudimentary methods.
Indeed. It's a story of continuous improvement, driven by the need for clearer, more reliable communication. Watson's contributions are truly remarkable, showcasing his ingenuity and persistence in overcoming technical hurdles. He deserves a lot of credit for shaping the early days of telephony. And that's it for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the surprisingly strange superconductivity of layered graphene. It's a fascinating area, isn't it?
Absolutely. The fact that these ultra-thin sheets of carbon can conduct electricity with zero resistance at low temperatures is mind-boggling. But what's making it so strange?
Well, two independent experiments are shedding light on this. Researchers looked at kinetic inductance, essentially, how hard it is for the current to change, in both 2-layer and 3-layer graphene stacks. The key is that these graphene layers are twisted at specific angles.
Right, the twisted angle is crucial. But measuring kinetic inductance in these tiny graphene flakes sounds incredibly challenging.
It was. Standard techniques were out, so they used a clever setup involving microwaves and precisely controlled temperatures. They had to innovate, because the samples are so small. The signals were incredibly weak. We're talking about truly cutting-edge experimental techniques here.
So what did they find?
For 2-layer graphene, the superconducting current was much stiffer than predicted by conventional theories. They linked this to quantum geometry. The shape of the electron's wave functions is playing a major role. It's a completely unexpected finding.
Wow, quantum geometry. That's pretty advanced. And what about the 3-layer graphene?
That's where it gets even more interesting. The kinetic inductance in 3-layer graphene showed surprising similarities to a completely different class of superconductors, ones that operate at much higher temperatures. This is huge.
So could this lead to room temperature superconductors? That's the holy grail, right?
Exactly. The researchers suggest these experiments might reveal key properties needed for room temperature superconductors. It's still early days, but the implications are enormous.
Think radically reduced energy consumption in countless devices. It's incredibly exciting.
It is. And it's not just theoretical. There's already talk of applications, like using this in smaller, lighter particle detectors for space missions. That's a practical application stemming directly from this fundamental research.
Precisely. And the research isn't stopping with graphene. Other two-dimensional materials are being investigated, like tungsten diselenide. This is a rapidly evolving field, with new discoveries constantly emerging. It's a very exciting time for materials science.
I completely agree. This research is not only pushing the boundaries of our understanding of superconductivity, but also paving the way for revolutionary technological advancements. It's truly inspiring.
Absolutely. And that's all the time we have for today. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the fascinating world of layered graphene superconductivity. Goodbye, and stay curious.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a staff engineer position at Zep AI, a Y Combinator-backed startup. It's a really exciting opportunity, wouldn't you say?
Absolutely. The salary range alone is impressive, minus $150K to $250,000, plus equity. But beyond the compensation, what really catches my eye is their mission, building the foundational memory layer for next-gen AI agents. That's cutting-edge stuff.
Precisely. They're aiming to create a continuously learning knowledge graph, enabling AI systems to develop a rich, temporal understanding. Think of it as a supercharged memory for AI, allowing for more personalized and accurate applications. They've already got clients like Mattel and WebMD, which speaks volumes about their technology.
That's a strong client list. And the fact that they've published a research paper, even if the link seems a bit futuristic with that 2501 date, suggests a serious commitment to innovation. What are the key responsibilities for this staff engineer role?
It's a pretty comprehensive role. They need someone to provide technical leadership across the entire service, from infrastructure and APIs to the front end. They're looking for someone who can handle architecture, scalability, security, and reliability. It's not just about coding, it's about shaping the technical strategy.
I see. It sounds like they want a true architect, not just a coder. They also mention working on temporal fact management and real-time graph updates. That's deeply technical work, requiring a strong understanding of data structures and algorithms.
Exactly. And there's a significant emphasis on collaboration. They want someone who can mentor junior engineers, partner with the founder on the product roadmap, and work with other teams to improve their SDKs. It's a leadership role, no doubt.
The requirements are pretty demanding, too. 7+ years of experience, expertise in at least 2 of Python, TypeScript, or Go, a strong foundation in system architecture. It's a high bar, but the compensation and the opportunity to shape the future of AI memory technology certainly justify it. What about the interview process?
It's pretty standard for a senior role. A phone interview with the founder and chief of staff, followed by a technical interview with the founder and engineers. Then, you'll need to demo a project or complete a technical case study. And finally, a meeting with the founder to discuss the role in more detail. Reference and background checks round it all off.
Sounds intense, but fair enough. Overall, this seems like a fantastic opportunity for a senior engineer passionate about ACE and I, and looking for a significant leadership role in a fast-growing startup. The location flexibility is a nice bonus, too.
Absolutely. It's a chance to be at the forefront of a really exciting field. If you have the skills and experience, this Zep AI staff engineer position is definitely worth considering. Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of Inco's borrow checker, or rather, the inevitability of its borrow checker, as explored in a recent article. The core issue? Balancing the speed and efficiency of stack allocation with the safety and flexibility of heap allocation. It's a classic trade-off, isn't it?
Absolutely. And Inco, with its unique approach to single ownership and move semantics, makes this challenge even more interesting. So how does Inco currently handle this? Heap allocation by default, I presume?
Precisely. By default, types in Inco are heap allocated. This offers great flexibility, allowing values to be moved around even while borrowed. The mechanism uses reference counting. Each heap type tracks its borrow count. A zero count before dropping is fine, but anything else triggers a runtime panic. Uncatchable, mind you.
Right, the classic reference counting approach. But that heap allocation comes with overhead, right? Pointer chasing, memory usage. The whole shebang.
Exactly. The overhead isn't just the allocation itself. It's the pointer chasing, the reduced optimization potential compared to stack allocation, and the extra memory needed for the borrow counter and method table. At least 16 bytes per heap type. That's where the inline modifier comes in.
Ah, yes, inline types. So these are stack allocated? How does that change the borrowing game?
Yes, inline types are stack allocated. The interesting part is how borrowing works with them. Instead of managing a borrow count, when you borrow an inline type, it's copied. If it contains heap allocated fields, those are borrowed individually. This cleverly maintains borrow validity without the overhead of reference counting for the entire inline type.
That's a neat trick. So, it's a copy on borrow strategy for inline types. But what about the limitations? The article mentions some.
Indeed. There are two main limitations. First, if an inline type has many heap allocated fields, borrowing it requires many individual borrow increments, negating some of the performance benefits. Second, and more significantly, you can't assign new values to fields of inline types. This prevents subtle, hard-to-debug issues related to aliases and inconsistent views of the data.
I see. So the immutability of inline type fields is a deliberate design choice to maintain consistency and avoid unexpected behavior with aliases. But that limitation restricts the use cases for inline types, doesn't it? Iterators, for example, often need mutable fields.
Precisely. That's the crux of the problem. The author explores several potential solutions, allowing field assignments with a copy-on-move scheme, introducing unique types, escape analysis, and finally, compile-time borrow checking. Each has its own set of challenges.
Let's briefly touch upon those. Allowing field assignments seems fraught with complexity, potentially requiring runtime checks and a complicated copy-on-move mechanism. Next. Unique types, while elegant in concept, seem to introduce significant complications with composition and closures.
You're spot on. Escape analysis, while appealing in its potential to automatically optimize heap allocations, is likely to be too conservative to provide significant benefits in practice. The author concludes that compile-time borrow checking, similar to Rust or Austral, might be the most robust solution, but also the most complex to implement.
So a classic dilemma, simplicity versus power. It seems Inco faces a difficult choice. The author suggests that a borrow checker is inevitable, but the implementation details remain a significant challenge.
Exactly. The article concludes with a sense of thoughtful uncertainty, highlighting the trade-offs involved and the ongoing exploration of different approaches. It's a fascinating look into the design choices and challenges faced when building a language with strong memory safety guarantees. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Inco's borrow checker. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Pantograph, a revolutionary structure editor. It's not your average code editor. It operates directly on typed syntax trees, offering a whole new level of fluidity and precision.
Wow, sounds intense. So, instead of manipulating text, users interact with the underlying structure of the code? That's a pretty significant departure from traditional editors, isn't it?
Exactly. Think of it like this. Traditional editors are like working with Legos one brick at a time, whereas Pantograph lets you manipulate entire sub-assemblies. This is especially powerful when dealing with complex code structures. The core concept is zipper editing, which allows for incredibly intuitive manipulation of subtrees.
Zipper editing, intriguing. Can you elaborate on how that works in practice? I'm picturing some pretty advanced UI interactions.
Absolutely. It uses a concept of tree selections, allowing edits within a specific subtree without affecting the rest of the program. Imagine you need to refactor a section of code. With Pantograph, you can select the relevant subtree and move, modify, or even delete it, all while maintaining the overall program's structural integrity. The GIFs and the README illustrate this beautifully.
I see. So it's not just about structural manipulation, it also handles type checking, right? That's a huge advantage for maintaining code correctness.
Precisely. Pantograph is designed for well-typed programming. It's not just about syntax. It deeply understands the types within the program. When you make an edit, it automatically adjusts the types to maintain consistency. It even handles more complex scenarios, like adding higher-order arguments, seamlessly. But it doesn't always automatically fix everything. Sometimes it leaves errors for the user to resolve, which is a deliberate design choice.
That's interesting. Why wouldn't it always automatically fix type errors? Isn't that the whole point of a type-aware editor?
That's a great question. While automatic correction is often beneficial, sometimes it can unintentionally overwrite the programmer's intent. By allowing some errors to persist, Pantograph gives the user more control and avoids potentially destructive automatic fixes. It introduces concepts like free variables, commented applications, and type error boundaries to manage these situations gracefully.
Okay, that makes sense. It's a balance between automation and user control. So this is all implemented in a language-agnostic way, correct? The README mentions a generic implementation.
Yes. The core of Pantograph is designed to be language generic. You define an editor specification, and the system handles the rest. The language.pantograph.generic modules are the heart of this, providing the underlying mechanics. The language.pantograph.specific modules then provide implementations for specific languages. It's a really elegant design.
This is fascinating stuff. The potential applications seem immense. It's a significant advancement in code editing technology. I'm definitely going to check out the online demo and the POPL paper. Thanks for breaking this down for us.
My pleasure. And don't forget to check out the presentation video. It really brings everything to life. Thanks for listening to Tech Bytes and News. Have a great day, everyone.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.